Hi, I'm Andy, and this is my lesson on subclass methods in Java. In this lesson, I'll show you how to add new methods to a subclass. I'll also show you how to override methods inherited from a superclass. Lastly, I'll show you how to use the super keyword in a method. Let's get started. Let's continue to work on the book class from previous lessons. In the last lesson, we added a constant, an instance variable, and a constructor to this class. Now we'll add a few methods. Remember, since this class inherits from the storeItem class, it already has all the methods listed in that class. So it already has a bunch of accessor methods, but it doesn't yet have one for the author variable. Let's make that first. So this is how a subclass can have a method that's not in its superclass. You simply add it to the subclass like you would any other method. This class also needs to change how some of its superclasses' methods behave. For example, here's the superclass's getCost method. But the shipping cost for books is different, so their cost will be calculated using a different formula. So when we ask a book object to give us its cost, we don't want it to use the storeItem calculation. We want it to do its own calculation. To do that, we need to override the getCost method here in the book class, meaning we need to provide the book class with its own version of the getCost method. To override a method in a subclass, you start with the @override annotation. This annotation is not necessary, but it's a really good idea. It tells the compiler that we intend to override a method. And if we somehow mess up the method spelling or list of parameters while doing so, it should let us know by giving us a compilation error. After that, we simply put the method. To override the method, it must have the same return type, method name, and parameter types as listed in the parent class. So I recommend just copying and pasting that information over. In the method body, we need to return the cost for multiple copies of this book. That calculation will look just like the one in storeItem, except we'll use the book shipping cost per pound to calculate the shipping fee. And we need to charge a shipping fee for each copy ordered. Notice we also had to use the getPrice and getWeight methods here, since the price and weight instance variables are listed as private in the storeItem class. Let's see how this works. Over in main, we'll make a storeItem object and a book object. Notice the two objects have the same weight and price. Then we'll print the cost of 5 of the storeItems and 5 of the books. Notice the costs for the storeItems and books are different. That's because when we called getCost on the storeItem, the version in the storeItem class was executed. But when we called getCost on the book, the version in the book class was executed. The rule for methods is this. When you call a method on an object, first Java checks to see if that method is listed in that object's class. If so, that's the version that executes. If not, it looks in its parent's class. And if it's not there, it looks in the parent class of that parent class, and so on up the inheritance chain. Here's another example that can be quite tricky. Let's see what happens when we call the no argument version of getCost on both objects. Again, we got two different results. Let's see why. When we called getCost on the storeItem object, Java found the method in the storeItem class and executed it. During that execution, the other version of getCost was invoked on the object, causing this method that's also in storeItem to execute. Now let's see what happened with the book object. Since it's a book object, Java first looked for the no argument version of getCost in the book class. It wasn't found. So the version in its parent class, this version, ended up executing. During that execution, this line of code was encountered. This is the tricky part because there's a version of this method in both the storeItem and the book classes. Which version actually executes? Well, remember, when you call a method within a method, it gets invoked on the object that the first method was invoked on. It gets invoked on this. And in this particular case, this refers to a book object. So the getCost version in the book class is the one that executes. That's why our two different objects gave us two different results for getCost. The storeItem ended up calculating the cost with this formula, while the book calculated the cost with this formula. Okay, now we need to override the toString method. In the storeItem class, this method returns the values of the 5 instance variables, each one separated by a new line. We want the book class to do the same thing, except it needs to include the 6th instance variable, the author. The easiest way to do that is to have the book's toString method first call storeItem's toString method, and then simply add the author information to that returned string. To call a superclass's version of a method, we use the super keyword, like this. Then we can append a new line and the author information. Lastly, we need to return the book info string. Let's test out the toString method for both our storeItem and book objects and make sure the right version of that method is executing for each. Good. So notice that the storeItem's toString method did not return an author, but the book's toString method did. This is exactly what we wanted to have happen. And that wraps up this lesson on subclass methods in Java. I'm Andy. Thanks for watching and coding with me today.